All right, 13.5, apply the law of sines. So the law of sines, it can be written in either of the following forms. For triangle ABC with sides of length A, B, and C. So I'm going to draw a triangle. So just for perspective, like this is not a right triangle. Okay, these are anyways, they don't have like a 90-degree angle, so they're going to be all different. And there's going to be different scenarios we're going to be working with. But so the law of sine says the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. Or we can flip them all and have A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. And so which one you pick is really just what thing are you trying to find. So like if I'm trying to find a side length, I'll use the bottom one. If I'm trying to find an angle, I'll use the top one just because there's less work involved. But they're equivalent, so you can use whichever one. And most of the time, we'll just have like the sine of A is equal to, or the sine of A divided by A is equal to like the sine of C over C. We're not going to have like all three written together. But using that, any sequence of those we can have, you could use A and C, you could use A and B, B and C, so on and so forth. To find what you're looking for, we just look at what piece do I know everything about and what am I trying to solve for. So normally they'll give you 3 pieces of information and then you will have to solve for the other 3. And so the angle side angle or the angle side case produces one triangle every time. You're probably like, what in the world? Why would there ever be more than one triangle? Well, you'll find out in a minute. But if we have this case, where they give you an angle, the side, and another angle, so maybe this stuff is ringing a bell from geometry, maybe it's not, or they give you an angle, and then a side, we'll be able to use that information to solve for one triangle. Okay, so we would use the law of sines to help us solve that triangle out. So I'm going to do an example of that for you really fast so we see that and just how we would apply this law of sines to that. So solve triangle ABC with angle C being 107 degrees, angle B is 25 degrees, and side B is 15. So I'm given 2 angles and a side, so that's going to be the angle side case here. So I'm going to set up my triangle. So I'm just going to, for consistency, go with what I had written up here, the way I did this triangle. So this is going to be angle C, and that is 107 degrees. Angle B is here. This is going to be 25, and obviously it's not proportional. And then side B is down here, and that is going to be 15. So ultimately, I'm trying to solve for all the pieces of my triangle, so side A, side B, side C, angle A, angle B, and angle C. So I know I have some information given to me, so I always will set it up like this, so that way I have all the pieces together and I can make sure I get everything. So right away, what other piece of information can I find?
Angle A.
Angle A, and how would I do that?
By subtracting 107 and 25 from 180.
Yep, so I'm going to find angle A by doing 180 minus the other two angles, so 107 minus 25, and it's going to be 48 degrees, so that's going to be 48 there. I'm going to write it in here. So now I just need to find the other two side lengths for that using the law of sines. So since I need to find side lengths, I'm going to choose this scenario here where the side length is on top. So I've got to have one that has unknowns and then one where I know everything. So the piece that I know everything for is B. So I'll have B over the sine of B, and then I'll be solving for A and C using B. I would always use given information for solving if possible, because if you happen to do math wrong somewhere and you go to solve it and you had gotten a wrong answer and then you go to solve another piece with that wrong information, you're going to definitely get that one wrong. So I will always use given information as much as possible to solve, just because that way it's less likely to have like user error. So I'm going to have A over the sine of 48 is equal to 15 over the sine of 25. And just something to note, your calculator will need to be in degree mode for these problems. So for 13.5 and 13.6, you will need degree mode for all of that. So I multiply by the sine of 48. So A is equal to 15 sine of 48 over the sine of 25. So then, make sure my calculator's in the right mode here. I'm not. So I would just type that in. And it's going to give you a number with decimals like most of the time. I'm going to tell you just round to the nearest whole number for everything. It doesn't specify in the book. They're going to round to like 1 decimal, but I'm just going to tell you to go to whole numbers because it's going to make your life easier. So A is going to be 26. So this side length is 26. And then for C, I'm going to do the same thing. So I'm going to use the B information again. So I'm going to have C over the sine of 107 is equal to 15 over the sine of 25. So C is equal to 15 sine of 107 over sine of 25. And then if you type all that in, you're going to get, it's going to round up, so C is equal to 34. And so you've used law of sines and solved for that entire triangle now. So this is the easiest scenario, is when you have angle side angle or angle angle side. What you're going to see when we move on is that there are other cases that get a lot more difficult. So this one is going to be one that Mrs. Marshall told you didn't exist. Okay, she told you that side angle was not a thing, more than likely. She told my class it wasn't a thing. And that's true in geometry, we don't deal with it. However, when you get to Algebra 2, it is a thing. And it can produce no triangle, 1 triangle, or 2 triangles. So how do we know? Well, there's going to be a chart that we're going to look at, but I'm going to have a little bit of writing that goes before it. But I'm going to give you a chart that's going to help you to know how many triangles you're going to have for a given scenario. Okay, so that's if they give you two sides and an angle, then we have this case. So possible triangles for the side-side angle case. Consider a triangle in which you are given side A, side B, and angle A. By fixing side B, and angle A, we can sketch the possible positions for side A to determine the number of triangles. That will be formed. Note, there's this formula that you need. H is equal to B sine A. Now, the other thing I'm going to tell you is that you won't always be given side A, side B, and angle A. Okay, they might give you side B, side C, and angle B. Okay, you can be given different pieces of information. So what you need to know about this formula is that it's the side that doesn't have the angle given and the sine of the angle that is given. Okay, so if they gave you different pieces of information, it's always the side length that doesn't have an angle with it. That's like a given value, and then it's the angle that's given because they only give you one angle because it's side angle. Okay, and that's going to be true for all of this going forward. So for this chart that I'm about to write for you, that's going to be the case. You're going to have this, like, whatever piece of information you're given. Side B is always getting fixed in whatever, or so the side that doesn't have the angle with it is getting fixed, the other angle is getting fixed, and then that other side is what is changing. So we're going to end up having 6 possible scenarios here of what this can produce. We're going to have 2 under A is obtuse. Okay, do we know what obtuse angle is?
Oh, it's bigger than 180. Or bigger than 90.
Bigger than 90. Okay, so if it's bigger than 90, it is obtuse. Obviously, if it's right, we already know how to deal with that. So we don't have to worry about that. But the other option is going to be A is acute. Okay, meaning what? Smaller than 90. All right, so I'm going to slide this up because I'm going to need all of this space. Throw this over here. All right, so I'm going to draw the setup over here, and then we'll talk about them, and then I'm going to do the same thing over here. So this one's going to end up having 4 in this box. I'm going to have 2 over here. So basically, we have something that looks like this. And I'm going to give you 2 scenarios that go with that. So this is side B and angle A in both of these cases. Then side A, okay, that would be the other piece that was given, or we're going to have a scenario with it being here, and then a scenario with it being here. All right, so the whole time we're doing these, I'm going to be doing this as if there's like a string attaching it. So like basically, I'm going to be taking and imagining right now my pencil's a string. Okay, I'm going to be taking it and I'm going to be drawing a line and I'm going to see where it intersects with this side over here. Okay, so in this case, or if it doesn't, then we have no triangle. So up here, this piece, if I swung it around, it never intersects down here. Okay. So that means that A is less than or equal to B. Okay, so side A is less than or equal to side B. Then we have no triangle. And those are the best ones because there's no work other than showing that A is less than or equal to B. Then down here with this one, we have a piece here. This one, when it gets swung around, okay, it intersects one time down here. And so when A is greater than B, we have one triangle. So the very, very first thing you do when you start a problem is you're going to look and see what case you have, okay? Because if we had one of the first two cases where it was angle, side, angle, or angle, angle, side, we know that we automatically have one triangle. The next thing I'm going to go to is I'm going to say, is angle A obtuse, or whatever angle is given? Is it obtuse or is it acute? And then I know where to go from there, okay? The obtuse is the easier of the situations. Okay, acute is going to be much more involved. And then from there, if it's obtuse, I'm just looking at is the side that matches the angle less than or greater than the other side there. So on to the slightly more involved ones. So I'm going to draw all four of these again. All right, so in all of these, you're probably like, where's that H coming into play? H comes into play on the acute ones, okay? So, H is going to be the, like, height here, like when we've done area problems for triangles in the past. H is going to be this part right here that basically makes a right triangle kind of thing. Right angle with it. All right, and these are all going to be still angle A and side B. So angle A and side B are fixed in all of these. So in this first one, consistency here, I'm going to have this be side A. So now here, this, if I swing it around, okay, it doesn't intersect anywhere down here. Okay, it doesn't intersect anywhere down here. So H is greater than A. And I will have no triangle. Over here, I'm going to make this A. So when it swings through, it's hitting exactly one time. So in this case, H is going to be equal to A. And with this scenario, we have one triangle. I'm going to do this one next. This one is here. So side A is over here. This one swings around and it also hits only one time. So in this case, A is greater than or equal to B. So this one doesn't involve H. It's the only one that doesn't involve H. And in that scenario, we have one triangle as well. Now my final scenario, it's going to be here, but it's also going to be here. So in this case, when it swings through and hits twice. It's not a very good arc there. It's not a good arc, but anyways, you get the point. Swings through and hits twice. So we have, in this case, H is less than A is less than B. And so here we have two triangles. All right, so I'm checking which situation I have, if I have side-side angle, okay? First thing I check is the angle that's given obtuse or acute, okay? If it's obtuse, great. I'm just looking at the relationship between the side that goes with the given angle compared to the other side, okay? And if it's less than or equal to, then I have no triangle. If it's greater than, I have one triangle. If it's acute, my first recommendation is to see if the side that matches the given angle is greater than or equal to the other side. If it is, I have one triangle. If it's not, then my next thing is to go and solve for H. Okay, this is where H comes into play. So that's B sine A, or the side that doesn't have the angle and then the other angle, or the angle that's given. And then I'm going to look at H compared to everything else I have. The worst scenario, or the hardest scenario, is when it's two triangles, because obviously that means twice as much work that you have to do to solve that. No triangle obviously is the best. Those are the ones that, other than finding H and showing that H is greater than A, there's no work, so that's nice. One triangle is not too bad. I mean, we've already done one where we solved one triangle up there. It was just a different scenario. So those are the different scenarios we have for that. So I'm going to stop this. So I actually have a notes